Now I'll be covering simulation flow using Vivado. We already covered with Verilog, but if you have already installed Vivado, then you can use Vivado for simulation instead of installing Verilog. In Vivado, first thing we do is there are multiple ways to do that, but generally what we do is that we create a new project. Uh, we give it a name. For example, I'll give it a name, maybe counter project. I'll, I'll create it on my desktop, and it's an RTL project. If you already have some files, then you can add them there, but I'll just add new files. Next, we don't need to add constraint files because we are just simulating. Normally we select some board here, but since we are just simulating this, so we don't need to select any board as well. So that's it. This will create a project, an empty project, nothing in it except project files and related stuff. So once the project is created, we can add new files. So I can add source, add or create design source. Okay. Uh, and I want to create a file, and I want a Verilog module, so I'll just name it counter. Okay, and I'll just finish. uh, we can give port names and inputs here, but I won't do it. I prefer using an empty file. So here's the counter module. uh, I'll just copy paste the code from the slides that we used. So I'll just replace everything with this code. So this is the counter that we designed. So maybe if I can. Okay. So next thing, if I want to add some test bench to simulate, so I'll add source again, and again I'll create new file. Here there are options like Verilog and VHDL. I just want Verilog, and right TB counter, which is the test bench. So I'll just create that file. I don't want to give any inputs or outputs at the moment, and that's it. So now I have a tb counter.v as well. So I'll just copy paste the code from tb counter that we covered in the slides. Uh, so I'll just replace it. Uh, when we are using Verilog, using Vivado, we don't need to use dump bars or dump files. So I'll just replace it, delete it, and then I'll come to. Also, we can use $stop instead of $finish, but I don't think that will make any difference. I'll keep it that way. So that's it. That's how we add files, and so Vivado automatically updates it, and it has recognized that we have a top level simulation file TB counter, and then we have a test bench. So to simulate the design, we select the test bench file and we just run simulation. So run behavioral simulation. It will start the simulation. And now you can see that it has run it and it is stopped at $finish. And if we look at the waveform, we can see the signals. We can zoom out. This will zoom to full view, and I can see that initially, maybe I can make it a bit bigger like that. So initially we had a reset. After reset, I should zoom in a little. At this posage clock, we had a reset, and the count goes to 0. After that, when on this posage clock was the first time that we had increment is equal to 1. So counter value incremented from 0 to 1. and then it was again incremented and it went to 2. On this posage clock we had a decrement, so it got back to 1. So this way we can actually simulate using Vivado, and at times when things don't work out, we need to debug it. Here we can only see the signals from the test bench, but if we want to see the signals of counter, so counter's module name was UUT. If I uh, see the test bench code, you can see that the instance name was UUT. So this UUT means that it's the counter. I can add this to waveform view, and here you can see the signals are added, but you can see that we can't see the signals here. If we want to see those signals, we have to restart the simulation. You can actually do this from here and rerun again. So, or you can type in the console. So if I, let's say, do it here, then you can see that here the command was given restart. So you can write restart here and it will do the same thing. So restart restarts everything, and then if you run all, it just runs till it encounters a dollar stop or dollar finish. So in this case it's dollar stop. So here you can up, for some reason. Okay, let me see why aren't the signals here. Maybe because of dollar finish. Let me see if I change it to dollar stop. I don't think it should work actually, but so if I change the code, I have to run simulation again. So I'll run variable simulation again. So it's probably because I encountered dollar finish and it just ended the simulation. If it had been dollar stop, then we can rerun the simulation. So when I rerun the simulation, it asks me whether I want to save the waveform file, these symbols, and I said yes. So because it needed to close existing simulation, so it just closed the existing simulation and rerun the whole simulation again. And now you can see that these signals are there. So now you can see the signals from inside the UUT as well. You can add dividers here. For example, if I want to have a divider, I can say that UUT signals, and this clock is from inside UUT. So I have a neat divider that these are test bench signals and these are UUT signals. And if the thing had not been working properly, if we, let's say, counter was not incremented, then I could have seen why it's not working. I could have seen why whether mux out value is correct or not, whether enable is correct or not. These are the signals that were actually input to the count register and enable of the count register. So these values will give me a chance to backtrace, and that's the main reason we use simulations. So that's it. That's how we simulate in Vivado.